Hello, everyone. Thank you for joining me today. My name is AJ Kuftic, and I'm Principal Technologist with Expedient, and we're going to talk about cloud-native approaches to your new and legacy apps. We are recording this right now so that you can have the best experience in everything that's going on right now. I'm actually available right over here in the right side in the live chat, able to answer as many questions as I can. But for the rest of the time, welcome to our session. For those of you who are new to Expedient, we were founded in 2001. We started in co-location, moved into managed services, and are now in cloud. We have cloud locations US East, Central, and West. Our West region just opened in Phoenix, Arizona at the end of 2019. We have international cloud deployments on customer sites in Australia, Germany, and Canada. So if our cloud locations don't work, we can bring that cloud to you. We've been a VMware cloud provider since 2007, and we are a Rancher Platinum partner. And thus, I just wanted to give you guys a little background on who I am, what our company does. But for now, let's actually talk about your applications. And before we get into that, I want to talk about the application triangle. Every application, whether it is a commodity off the shelf piece of software or a homegrown piece of software, everything generally goes to the application triangle. For the vast majority of what I'm going to talk about today, I want to talk about homegrown and internally developed applications. And I'll talk about why a little bit later. When we start looking at the application triangle, I want to start with our infrastructure team. And our infrastructure team are basically the people who have had to build everything from the ground up: the servers, network, storage, where files live, backups, disaster recovery. These are the people who make the base of your IT go. And they're generally focused on security and control. We want to make sure as infrastructure people that we are making sure that everything that we do is done in a secure fashion and is done to general standards and procedures. And a lot of that comes back to the ability to support these things going forward. And as you start to want to build cloud native applications, this is where your infrastructure team starts to get a little nervous, because by and large, they know VMs, but they don't know cloud. And this is really the next level for a lot of the people in the infrastructure organization. But this isn't as easy a jump as, say, client server was to virtualization, right? Where you're running the same sort of operating systems. There's just not hardware that you are directly interacting with. You're interacting with virtual hardware. In this sort of instance, you're really turning the apple cart over. And so that can make a lot of infrastructure people very nervous and sort of hesitant to embrace a cloud native technology. At the top, we have the business. And what the business really cares about is agility and speed to market. Every conference that they go to, and by the way, we're here at this delightful event, but the business side goes to their own event that are very industry specific, things like healthcare conferences, retail conferences, manufacturing conferences, and they keep hearing that the cloud is the way forward for them. This is how they're going to be more agile. This is how they're going to take on new challenges and adapt to change in the marketplace. But they don't exactly know what cloud is. They just hear the word, right? They hear, oh, we need to go do cloud stuff. That could mean anything, right? That could mean we want to go take on software as a service, right? We don't want to deal with email anymore. We want to use Office 365. That's a cloud service. Or going all the way down to, we don't want to be in the data center anymore. We want to move everything out to the cloud. That's a much different story. So helping the business understand these applications and where they're coming from and why they are the way that they are. We also have our developers. And these are the people that we're going to talk to and about the most here. And our developers, they know that their applications are not terribly good. Right? They've seen the inside of their code. They've seen every last little thing that they've had to put into place, every workaround, everything that they've done to make the application work the way that people are asking them to make it work, right? Every feature request, every bug fix, everything that they've done is to make these applications run. And they want to modernize them too, just as much as you do when you say, oh, these applications are old, these applications aren't very good anymore. They want to modernize too. The problem is that takes time. And there's a lot of risk involved. So if they're going to do it, they want to do it in the most freeing way possible. They want to take on new platforms. They want to take on new capabilities to make their application as good and as strong as possible. And a lot of times this leads them to a hyperscale cloud because they can go out there and they could take their credit card and they can swipe it and get themselves access to a service. They can get access to the things that they want to use without having to really worry about, the security and the control aspects, because they want to take and own that whole thing start to finish. And that's a lot of what drives DevOps, is the ability to kind of get all the silos out of the way. They want to move as fast as they'd like to, and they want to do that inside of their own team. So when you're starting to look at this, there's really three semi-different aspects all trying to come together to one middle point. So let's dive into the applications as they are now, and let's talk about those legacy applications. Let's talk through where these applications started, right? And all these applications really started with a 1.0. This is the base idea. We want to take on a new challenge. We have this problem, we want to fix it, and here's the application that we want to use to do it. And so they start to build their first idea. Maybe it's something like, we have all this user data, but we want to organize it and sort it so that we can make sense of it and utilize it in the future. And that's base application 1.0. But is 1.0 perfect? No, it's not. And that's where updates 1.1 through 1.4 come in. Some of those are bug fixes. Some of those might be small feature requests, things like, hey, this, the user data is all in here and it's really great that it's all together and I can see it in a big table, but can I sort the columns? And that might be update 1.2. But then someone comes along and says, well, now that we have all this user data and it's sorted, can we use it to automate promotions? Cool, there's your 2.0 function. That's the next big tentpole feature. And then someone says, well, now that we have this ability to take this data and automate out, promotional email, how do we take this and maybe integrate it with other systems? Oh, there's the 3.0 code base. And now this application that started as just, we want to take this data and kind of sort it a little bit, has turned into a fully automated, fully integrated system that is now crucial to the business. And so now I've got thousands, if not millions of lines of code involved. And the complexity of this application has gone up, but because it's this big critical application, no one wants to touch it, which means my agility with this application has dropped dramatically. And so now this application feels like a really heavy weight. And if we're going to move a big heavy weight, we need to start to distribute that work, right? So when we're staring at the big heavy weight here, it may take one or two people to move that. Or it might take one person if they trained a really long time to be able to pick that up and move or make any sort of move with it. But that's not efficient. That's not really going to be sustainable going forward. And if that person ever decides to leave, that weight's not going anywhere. So what if we started to break that big weight down? We take our big application and we start to break it into smaller chunks. So we take this application, we say, well, this is our big main retail site. And we start to break that down into chunks, like individual services, like this is the front end and this is the back end. Okay, now I'm only making back end changes that doesn't affect the front end. So now I can be more available during changes. Or I can make smaller changes and make them more frequently. It's not the best, but you've at least broken it down from one gigantic monolithic application. And then you can start to break that down into even smaller services and get it down to, okay, the front end is made up of the catalog system and the website and the image database. Okay, and then the back end is made up of the actual catalog database and order processing and fulfillment. And those can start to break down into even smaller services, and that gives you the ability to make smaller changes faster. And I know there's a lot of you who are probably saying, well, our applications are old and they're big monolithic applications, and this would be very, very difficult to do. Enter Twitter. Twitter in 2008 was a giant monolithic application. It was Ruby's on Rails. And everybody thinks that because Twitter is this, big web service and, lifeblood of current events, that it's, it was always written in the best way. No, it very much was not. It was a big monolithic app, and they had massive scaling issues, even though their principal engineer said, "We will not have massive scaling issues." It was an actual quote from him. And so they would have multiple day outages. And if you were on Twitter in 2008, you probably saw our good friend, the fail whale. Fun fact about the fail whale, that was actually drawn for a birthday card. Ended up becoming the 404 image for one of the biggest web services in the world. Life is funny. And they had 6 million users at the time, but they were more or less running up against a gigantic wall on how they could reach more users. And so what they kind of ran into was the end of Moore's Law. They ran into the problem of, we just can't throw more resources at this. And they were constantly trying to throw more physical resources at it. So let's start at the beginning here. Moore's Law, for those of you who are not familiar, was a famous law from Richard Moore from Intel, who came out and said that processing power will go up by X over the next X period of time. And that changed over time. Originally it was double, then it was like 1.8 performance. It changed from 12 months to 18 months to 24 months to 36 months. So Moore's Law has generally changed. It's not been a consistent law. It was consistent for a while, but it did not stay that way. But the challenge that we run into is that we kind of hit physical limits very, very quickly. When we started, we had an application living on top of an operating system, getting a bunch of gigahertz from the CPU. There's a limit to that. You can only hit so many gigahertz before you have to get into liquid cooling or liquid nitrogen cooling. We're still kind of hitting that limit now, even in 2020, at like 3.5 to 4 gigahertz is like the most you can get without having to resort to gigantic cooling mechanisms. And inside of data centers, that's really not a sustainable model. So what did we do? Intel, AMD, and other x86 manufacturers came out with the core model. And this allowed you to put multiple CPUs on one socket, and you could now hand multiple cores. So the applications had to be maybe slightly rewritten to be able to support multi-threading and be able to take on more cores and take advantage of the additional resources. But there's still a physical limit there. AMD's best processor is only 64 cores. And you can do multiple sockets, but you start to run into NUMA nodes and all sorts of other technical problems with trying to take advantage of as many physical cores as possible. And so we kind of went, well, how do we do this? Well, we go to a load balanced application and we deploy multiple machines with the same application and we load balance across them. The nice little side effect here is that you get more availability out of this because you can have one machine go down completely and still have your application be available. But now you enter into the challenges of maintaining load balanced and distributed applications. But the goal is to get to the full distributed application, having multiple instances that can be taken in and out at any given time and maintain maximum availability and take advantage of maximum performance from your physical resources. But there's a lot of challenges to this. The main challenge of distributed applications are management. Where do these things live? How do I inventory them? How do I keep track of where they actually live in my environment so that I don't put all of my eggs in one basket, all of my virtual machines onto one physical host? And this is also an opportunity for people to get clever, and they want to start to do things like, well, I'm going to distribute this across multiple hypervisors or multiple clouds. And they start to run into things like data replication, latency issues, network challenges that make the application more complex than even what it was before when it was just a code problem. You're adding infrastructure problems to code, and that's never a good recipe. Your infrastructure people will start to tell you that OS patching becomes very difficult. How do I know which ones I can take down at any given time? As code changes happen, does that change how I do my OS patching? And these things start to get very, very complex. Configuration management and security hardening, they go hand in hand. And this is where the developers start to run into challenges of how do I maintain consistent configurations across all of my nodes? How do I make sure that when I load the website onto one server that it exists on all of them all at the same time? On the flip side, you can use this to do blue-green deployments, but most people end up having problems in the configuration management and security hardening aspect versus getting the benefits of blue-green deployments. And finally, how do I actually scale this? Because the moment I go from, say, 4 nodes to 5, I have to do all of this all over again. Where do those things need to live? How do I patch the operating system? How do I make sure that the configuration lands properly? How do I get it into load balancing? All of these things are major challenges. And so this is where cloud native technologies can come in. First, I want to kind of define cloud native. And specifically, it is a how, not a where. You can do all of this on premises. And there's one big caveat that I'll get to in a minute, but you can do all of this on premises. So it's not necessarily that you have to run out to an Amazon, an Azure, a GCP to get the benefits of cloud native. But this is all based on doing modern development techniques and being distributed by definition. So when we're talking about this, we're looking at things like Agile, CI/CD, utilizing APIs and containers to deliver an application in the most efficient manner. All of these are based around sometimes making cultural changes like taking on Agile development techniques, but also CI/CD and making sure that your change control people, your ITIL people are okay with you making far more frequent changes, but making them smaller changes versus the big waterfall change weekend that happens maybe once a month. So these are big changes that you kind of have to take on and have to have a bigger discussion about. And so you have to enter the mindset. So when we're talking about this, we're talking about microservices. And again, that kind of goes back to that, the weight analogy. I want to take my services and break them down as small as possible so that when I make changes to them, I'm making them in the most granular fashion possible. So things like taking a retail site and breaking it down into things like catalog, order tracking, payment processing, and promotions, instead of just the retail website and the retail backend. By breaking it down, you can start to make those smaller changes. You can start to make more frequent changes that can allow your application to progress faster and react to business changes. Everything becomes a service and starts to operate independently. So you can start to do things like break up your stateless and stateful. Say, order tracking. It's a very stateful process. People want to log in and get to the order that they placed. They don't want to log in and see someone else's order. But things like the catalog front end is very stateless. It's always calling back into the catalog database because the catalog changes. You get new items, you have different pricing, maybe you have sales. All of those things can change, but that's all done at the data side, not at the application side. And Agile allows you to take more sprints so that you can take on these sorts of changes so that when the business says, hey, we want to enable bulk ordering. Okay, we can do that in a quick sprint. And then in 2 weeks, you roll out bulk ordering. At the same time, you can also say, hey, nobody's using bulk ordering. Do we really need this process? No. Okay, hey, customers, we're going to disable bulk ordering. If you want to do that, please contact us at 1-800-company. And you can do a bulk order that way. And so it's done as a better process for the business versus just trying to shove everything inside of technology. Speaking of technology, this is where we start to talk about containers. And the main aspect of containers is the ability to isolate your processes from each other. We want to make sure that everything inside of that process or inside of that microservice is everything that it needs to run. And this gives you the better granular change. So things like Python, anybody who's had to deal with frameworks or utilities or languages knows that you have to deal with that at an operating system level in a non-container environment. And while that can be a benefit in some instances, in a lot of other instances, when you start to break things down, things between like order tracking and payment processing, Python versions can be a problem. So let's say payment processing wants to use Python 3.7 because it has a security fix. You don't have to break order tracking, which would need to do a full regression testing to do a full Python upgrade, because they're in separate instances. Python lives in each of those containers. So you eliminate dependency testing between different versions and different languages. And the ability to use the best of breed languages and frameworks can go a long way here as well. So let's say you're a retail site. I'm sure that if I asked for a show of hands how many people actually enjoy doing PCI compliance, I'm pretty sure I wouldn't see a ton of hands go up. So the ability to offload PCI compliance when it's not your business model to do PCI compliance can actually be really helpful. So you can take advantage of something like Stripe or Square for your payment processing, let them handle the PCI so you don't have to actually store that. You're just making an API call out and getting the benefit of getting the better payment processing without having to take on all of the compliance overhead. And again, I mentioned that this is a how, not a where, but if you utilize a self-service elastic infrastructure, you're able to take advantage of scaling up and scaling down and actually paying for what you use. One of the big challenges of on-prem technology is that you are making a CapEx purchase to take on new resources. And that's not necessarily the best way to do that. And if you try to take that on and grow your business, it becomes a problem. So being able to take on a self-service elastic infrastructure allows you to take better care of your finances and better care of your technology purchases and be able to utilize spend and usage together. From a management standpoint, this is where we want to focus on those APIs, because now we don't have services running on the same machine anymore. They're not just talking directly to each other. They have to reach across the network to do that. But this allows you to take on those third-party services. We also want to isolate our individual components, because as we isolate these things, we can make sure that things like Python versions, Java versions, they don't conflict, and that our application can run as smoothly as possible going forward. This is also where automation and policies come into play. And because we have this automation, we can do all of that scaling as we start to see more users come in. So we don't have to remember, September 1st is when we do our big semi-annual sale. We need to make sure that we have everything available there. You're automated and everything scales up as users come in and then scales back down as users leave the site. And all of that is done by policy. If I see 70% CPU usage, go deploy another container, go utilize another service. And if you feel like you're late to the party here, you're not. You're not at all. We have cloud native technologies that are really just now starting to settle out and become more standardized. So 451 Research did a survey of their enterprise customers, and they found that only 17% of customers are utilizing containers fully across the board. That means 83% of companies are not utilizing containers at every single aspect. Now, that 32% is some adoption at a team level. That's the growing usage. So as you start to look at this chart, you want to start to be in the blue at a minimum, light blue at a minimum, but you want to start moving into that darker blue where you can say that, hey, we have it in use, and you can start to learn lessons inside of your company on how to best manage it for you. But as you start to go down the list, you see Kubernetes and serverless. Those are the hot technologies of cloud native. But you see that only 13 and 15% respectively are utilizing them fully. So there's still a ton of growth room for those technologies. And as they've started to settle out and become more available and more widely supported, you'll start to see that number creep up. But you're not late, you're right on time. So when we look at something like Twitter went and containerized their application. They were actually one of the first to really dive into containers and microservices as a real platform. And so outages became more rare. In fact, it was a few years ago that the fail whale actually popped up and everybody went, wait, I haven't seen this in a while. What fail whale's back? And we actually all celebrated the fail whale coming back because it was, a little bit nostalgic. But remember, they had 6 million users in 2008. As of June 2019, they had almost 350 million users. So you can see that scale goes up real fast. And that was because they were able to scale with it. So what's next for you? Developers and infrastructure need to work together. And that's due to the fact that cloud native is really a gray area. The infrastructure team needs to help support things. The infrastructure team needs to help them build it. The developers need to start to take on some of the infrastructure. They want to take on some of the infrastructure responsibilities. So coming to an agreement on how to best do that is going to be incredibly important. And look at what can make an impact and what causes pain. How do we make a better application? What is going to be the best bang for your buck? If you just move the image service to a microservice, maybe that's a good thing because now you can serve up images faster. You can utilize a content delivery network. But how do we start to take advantage of these services and take advantage of this in the most effective way possible and not just, oh yeah, we microservice to the backgrounds for our website. It doesn't really do anything. But being able to make an impact or resolve the causes of pain can be really, really beneficial. And finally, If you haven't read it already, please go out and read The Phoenix Project. It is a fantastic book that can kind of explain, and you'll probably see a lot of yourself and other people that you've worked with inside of the book. If you haven't read it, go read it. If you have read it, go back and reread it and really start to think about it. Now we have, DevOps is a more accepted and a better platform going forward and a better way to take on your applications. And with that, I'll turn it over for questions. I will be right over here this way. I'll be right over here in the chat, ready to answer your questions for about the next 15 minutes. And I hope you have a great day. Thanks.